Now the next topic, that is magnetism and Gauss's law. Okay. Now we already studied about the Gauss's law for electrostatics. Okay. And in that we discussed this thing, the electric flux associated with any closed surface, that is integration E dot dA, that is equal to the ratio of net charge enclosed by the Gaussian surface to epsilon 0. This Gauss's law we already discussed for electrostatics. Now we have to discuss Gauss's law for magnetism. So Gauss's law for magnetism says this thing: the net magnetic flux through any closed surface, that is 0. So mathematically, how one can represent this one? Say, suppose we have the magnetic field as shown in the figure, and in this particular magnetic field, we consider a closed surface. Now we want to find the total flux passing through this particular closed surface. So for that, consider any infinitesimal small ith surface element for which the area vector, that is delta Si, and the magnetic field at that surface element, that is Bi. Then we can write the flux passing through this particular ith surface element, that is Bi dot delta Si. Okay. So if we want to find the total flux passing through this entire surface, then we have to divide the entire surface into this type of so many infinitesimal small surface elements. Then due to each one, we have to calculate the flux passing through it. Then we have to take the summation of all those. Then we will get the resultant one. Okay. Now, so resultant flux, or we can say net flux passing through the given closed surface, that is sigma I equal to 1 to n 5i. This is the summation of the flux passing through all the infinitesimal small elements. So we can write sigma I equal to 1 to n Bi dot delta Si. Now here if we take limit delta S tends to 0, then the summation can be represented with the help of integration. So we can say the net flux passing through the given closed surface, that is given by integration B dot ds. Clear up to this? Now as per Gauss's law, the net magnetic flux through any closed surface, that is 0. So we can say this net flux integration B dot ds over the given closed surface, that is equal to 0. So this is the Gauss's law for magnetism. Clear? Now see, for electrostatics, we write the Gauss's law, that is integration E dot ds over the closed surface, that is sigma q upon epsilon 0. Now, exactly like this one, if we write the Gauss's law for magnetism, then integration B dot ds over the closed surface, that is the magnetic flux through any closed surface, that is equal to, now constant of magnetics, so that is mu 0. So here 1 upon epsilon 0, here the constant is mu 0. Sigma q, that is the algebraic summation of the electric charges. So here sigma qm, that is the algebraic summation of magnetic charges. But see here, as per Gauss's law, this magnetic flux through any closed surface, that is 0. So here, if we take this flux that is equal to 0, means mu 0 sigma qm, that is equal to 0. Mu 0 is not equal to 0. It implies that this sigma qm, that is the net magnetic charge enclosed by the Gaussian surface, that is equal to 0. So what this suggests? This suggests this thing, monopole does not exist in the nature. Because when we think about the summation of the magnetic charges, it implies that North pole that we consider as the positive magnetic charge, South pole that we consider as negative magnetic charge. So when sigma qm, that is 0, means single independent pole is not available in the nature. So this one is the proof of that thing. Monopole does not exist in the nature. Clear to all of you up to this one?